So today I'm going to talk about what Amazon Web Services, or AWS, provide, not to create themselves IoT or industrial IoT applications, but services and infrastructure which enable people to create industrial IoT or any kind of IoT, actually, applications. So we're going to look at very, very quickly the opportunities that industrial IoT provides. I'm really going to focus on one thing. I think everybody here is talking about that today. And then look at the challenges. Again, quite briefly look at the challenges and then get into the meat of what AWS provide. And hopefully, as I go through, I will address those challenges as I go through the talk. I'm going to bring the slide up with the challenges again at the end, just to check I didn't forget anything as I went through. And we have some real-world use cases as well to go through here. So the opportunities of the industrial IoT, well, I said I wanted to focus on kind of one thing, and that's really the capture of the data and the value of the data. So we have machines connected to each other, interacting with humans, interacting with the cloud, lots of data flying around, and we have real-time monitoring and real-time control. That allows us to collect that data and perform like machine learning algorithms and lots of other algorithms as well in order to make predictions or improve our process or do mass customization, that sort of thing. And that's what's making our factories smarter. And if we look at this, or traditional manufacturing, if you like, where we have product design, and then we are designing how we're going to make the product, and then finally we are making the product with all these software tools along the way. In our traditional process, and because I said I was going to focus on sort of data, on the end of there I'm going to put data and analysis. And what we can do is take our linear step-by-step process here for manufacturing and feed back that data and analysis to improve the process. So we're taking our linear process and creating a circle out of it. So there's this feedback loop that we are able to generate in order to continuously improve the product, improve the efficiency of the manufacturing, improve customer experience, adapt our business models, all these fantastic things. And in the middle of there, of course, is the data. And we can wrap that with artificial intelligence, AI. And of course, we're not removing the humans here. The humans are still interacting, but they're interacting in a different way. And they're presented with different information and automating what's going on. So that's my kind of focal perspective on industrial IoT. Like I said, it was very, very much data focused. And these are the challenges. In fact, I'm going to say there's two more challenges. Well, there's probably lots more challenges, in fact. But these are the three primary ones. Once we have connected our devices, of course, they're remotely accessible. So that obviously raises huge security questions. As we are creating more and more complexity, we've got messages going all over the place, humans interacting in different ways. We need to make sure that our systems can cope and we minimize the amount of downtime there. And also, a lot of our systems that are in factories now were never designed to be connected to the internet or to provide data. So we have to somehow cope with all these legacy systems that are in our factories already. To this, I'm going to add two more. One is scalability. I mean, connecting 10 devices is fine. Connecting 100, okay. Connecting 100,000, starting to sound a little bit trickier. So that's scalability, and also where we store the data. To get maximum value from our data, we want it to be collected in one place. We don't want like 10 factories storing their data in 10 different places in 10 different file formats. We need to collect all that together in order to extract the maximum amount of value we can get out of it. So they're the challenges I'm hoping to address during the talk. As I say, I'll go back to them at the end. Now on to Amazon Web Services. Cloud computing, what is it? Everybody talks about cloud. Amazon define it as the on-demand, which is very important because that's where our capital expenditure turns into operational expenditure. So the on-demand provision of IT services, infrastructure like compute, databases, storage, all that kind of thing over the internet on a pay-as-you-go basis. So there's no kind of subscription. You are just paying for what you use. So you can have peaks and troughs. You don't have to have that capital investment just to make the peaks. So there are something like 125 different services. That was the last time I checked, which was actually today, but they're introducing new services all the time. And you can see down here we have Internet of Things. But Amazon Web Services have been around in various different industries. Any vertical you can imagine can use Amazon Web Services. The Internet of Things is a fairly recent addition. And I'm going to look at how those services outside of that Internet of Things category, by the way, I should have said each of those icons there represented a category of products or services. We'll look at the Internet of Things one in more detail in a minute, but I want to just demonstrate how all of that infrastructure is used, and in a relevant way. Again, this is not a product. This is an enabler for people to create products, and this is performing an over-the-air update. When we do that over-the-air update, we are going to presumably have an engineer supply the operator with a new executable. That's going to be uploaded to the cloud. So we are using a storage service, S3 in our case, simple storage service. Then we want to make sure that the device is going to receive an image it can trust. So we're going to upload a signing certificate to the Amazon Certificate Management Service. We are then going to sign it using the signing service and deploy it using the job service, which is the screenshot that you can see here. See, there's a button down there for create an over-the-air update job. So if I come back to this, you can see that we've actually used lots of services. Compute, obviously, because we're actually processing things, storage. Security is particularly important. This is one of the challenges. So this is absolutely fundamental to everything that Amazon Web Services do. So we have our devices in the field that cannot communicate with the cloud until they have authenticated that the cloud endpoint is the one they are wanting to connect to. So that's all done using open standards, X509 certificates, and TLS. So there's nothing proprietary there. And then the cloud service has to authenticate that the device is the real device using the same method. And then I've mentioned the operator. As part of this security and identity compliance here, we have a service called the Identity and Access Management, where different operators can be given access to different pieces of functionality. So you may say, for example, that an over-the-air update thing is a really dangerous thing. If you get that wrong, you can cause havoc. So we'll say only one person in the company is permitted to upload a new image, and only another person is permitted to sign the image, because the signing is absolutely crucial, right? So we can really, really lock down the security of the devices, the security of the cloud, and the security of the operators throughout the whole process. So looking at the IoT service in a bit more detail, we're going to start on the right here. And here we have the IoT data analytics. This is really our goal for connecting these devices, is to extract value, maybe from just the fact that we can remote monitor everything, but primarily because we want to use these analytics services, machine learning, this sort of thing, to somehow extract value in whichever industry we are in. However, to get that far, we have to pass lots of gates. First of all, literally a gateway into the cloud. We have to be able to get the data into the cloud. And as I said, everything has to be locked down security-wise. And then we have to manage our fleet in that we have to provision everything to enable it to authenticate with the cloud. And then we have kind of auditing, making sure that the system is running correctly. That actually uses machine learning as well. So it learns how the devices behave. And if it sees a change in behavior, it will flag an anomaly. Might just be a software bug, right? Or it might be something more sinister. So you can see here that this is the bit. This is the bit we want to get to. But to get there, we have to get through all this infrastructure, which is really hard to learn how to do, really hard to deploy, really hard to maintain. But Amazon do all that for you, just so you can start by innovating with your products by collecting that data. And then on the edge, which Amazon define anything which is not in the cloud as on the edge. Coming from the microcontroller world, I now have to talk about the edge of the edge for the nodes in the system where the sensors are effectively. And on the edge, we have two pieces of software predominantly anyway. There's actually lots. Two major projects. One is a product called Greengrass, which is it's Linux software. And that allows you to move some of that cloud computing programming actually to run it locally on your premises. And that might be for a number of reasons. One could be that you're trying to do some control that just the latency of going to the cloud and back is too great. Another might be that you've got a very flaky internet connection. So you are having to cache things locally until the internet comes back. And this comes to, remember I was talking about downtime here. So we've got something which runs on the edge, which in an unreliable network situation can actually cache data for you. When the internet comes back, it can start talking to the cloud again. I should say on the point of availability as well, the cloud infrastructure used by AWS is the same infrastructure which is used by the Amazon retail service, which people are generally a lot more familiar with than AWS. So this is extremely robust infrastructure. There are 18 different, there's 50 odd availability zones in 18 different geographic regions. So there's a lot of redundancy built into the system. And these things are, they're millions of transactions per second. Even just S3, that simple storage service, which handles trillions of objects in there, can peak at millions of transactions per second. So you can see how really robust this infrastructure is. The other thing Greengrass can do, of course, is if it's just illegal to send the data to the cloud for whatever reason, and maybe it's medical data or something like that. So you can run that processing locally. And then there's the microcontroller devices. Now, there are something like 20 billion microcontrollers shipped every year compared to 1.4 billion cell phones and I think 350 odd million laptops or desktop computers. So this is a vast market, and this is where the FreeRTOS product sits. So FreeRTOS, whereas Greengrass is software that runs on Linux, FreeRTOS is libraries which provide scheduling. They enable the software, which is probably the smallest software in your entire system, but probably the one that proliferates the furthest, fans out the furthest, to be organized in a way which hopefully makes it maintainable. But the point in this diagram here, this is supposed to be your program space, okay? A light bulb's the simplest thing. It's a really boring thing to talk about in IoT, but in this case, I'll excuse it because everybody understands that a light bulb is really simple. And at the bottom there, we have the amount of code we need in order to actually program our functionality of our light bulb. So our light bulb has to turn on and off, fade in and out, change color. It doesn't really get any more interesting than that. But now we need to internet connect it. That means we suddenly need a communication stack, which is vastly more massive than the software I need to turn a light bulb on and off. And in there, there's a lot of processing timing and protocol management, serialization, deserialization. And then we need the security stack, and then we need to be able to store our secrets so we can authenticate correctly. And then we need OTA, and then we need bootloader and hell. All of a sudden, our light bulb has kind of ballooned into this massive software. So Amazon FreeRTOS, just like in the cloud, you have all that infrastructure which is provided for you to allow you to immediately make use of getting data to the right place in the cloud. Here, all this software, other than the functionality, is provided for your microcontrollers, so you can get them connected and sending data to the cloud much more quickly. So we're going to, there's a few use cases here. I'm only going to go through one of these just to show you how we can architect this system. And predictive maintenance is something which is really easy to understand for people. I've got an industrial scenario here where we have a load of motors that we want to monitor. It doesn't have to be this example, this pattern follows. It could be elevator motors, it could be anything, or lift motors, as we say in England. So using the Amazon software here, we can use Amazon FreeRTOS to put vibration sensors on, temperature sensors, that kind of thing. Use Greengrass as a gateway to get that data into the cloud, where we have vast compute and storage and database infrastructure that we can use on a pay-as-you-go basis. We can put all that data through some machine learning and create a model which we then send back down to Greengrass. In fact, I think I've got a diagram of this. I don't know why I'm trying to describe it. Here we are. So we've sent our data up to the cloud. We've got it to the analytics and the machine learning, and through this SageMaker is shown in this case. I think there's other ones you can use. And we send it back down to Greengrass. That's running the inference, which is going to check for anomalies. If we have our Amazon FreeRTOS sensors up here, if the temperature goes up or vibration, then it can send a message back through Greengrass, and we can maybe do something really clever like put it into a maintenance log for our maintenance person, and even schedule the most optimal route for the maintenance person to go around. So at every point, we are squeezing out the maximum efficiency. We don't have to send someone on site to look at a motor unless we know it's going to go wrong. And of course, the customer's delighted because it never breaks, in theory. And you're proactive rather than reactive. So these kind of on the same basis, predictive quality. Maybe you've got sensors in there that know when water's needed, how much fertilizer to put on the water. Maybe you've got a camera there which is tuned to know exactly at what point, what color and what size the fruit should be to go and pick it and schedule the fields to be picked in the correct order. These are all these are real examples, by the way. AWS customers are doing these things. We use this as an example of how IoT has real value today, which perhaps consumers don't see. And this example is a mining company who, they have these massive, great big trucks, and they cost a lot of money to maintain. And if those trucks go out of service, then they can't get the right amount of material out of the ground. So here they're putting Greengrass actually on the trucks, and it measures the vibration and that sort of thing. And then they have heat maps of where the road's getting really bad. And then they can direct the trucks around where the road's bad and send maintenance guys in there to smooth the road out and effectively make sure that the investment they have in their trucks, they get the maximum value out of them. The assets don't degrade over time as quickly as they would without this ability to collect this data and analyze it. Okay, so back to this. Did I cover everything? Security, I covered. Downtime, I covered. So there we've also got Greengrass, of course. and I mentioned the availability zones. Legacy equipment I didn't mention, so there, because we have compute on premises, with Greengrass you can put in protocol adapters. So for example, you might have UPC UA communications, which Greengrass can listen to and send that data to the cloud. What else did I say? Oh yes, keeping all your data in the same place. Hopefully that's kind of self-evident, because no matter where your factories are, you can send all the data to the same place. And scalability. Yeah, I mentioned scalability as well. I think I ticked off all the boxes there. And that's all I had to cover today. I will just leave that up on there, where it kind of maps AWS to various Industry 4 tenants. Thank you.